Hello friends, am I audible to all? Kindly give me the confirmations in the chat box. Okay, fine. Thank you all for giving me the response. So friends, in the previous lecture, we have completed the chapter that was the refrigeration and air conditioning. So from today onwards, we are starting with the discussion of the new chapter, that is chapter 4. The name of this chapter, that is properties of steam. Dear friends, let me inform you that the properties of steam is one of the important chapter if we consider the theoretical examination of GT. This chapter is having more marks weightage in the GTU examination. So it is very essential to prepare this chapter perfectly so that you can score good marks in the examination. So now let us proceed further and discuss the several points related to the properties of steam. So dear friends, these are the main contents of the current session. In this session, we will be understanding the basic concepts of the steam and vapor. Then we will be understanding the concepts about the steam formation. Moving further, we will be understanding the types of the steam, and finally we will understand two parameters in context of the steam. They are the dryness fraction and the wetness fraction. So let us start with the first point, the basics about the steam and the vapor. Dear friends, in simple terms, the vaporization is the process which produces the steam above a certain temperature. So during the vaporization process, the steam is produced above a certain temperature. Now when we consider the concept of vapor, the vapor is a general term, a group term, which is used for any substance. That substance can be either the solid or the liquid that undergoes a gaseous state, and that particular condition of the substance is considered as the vapor state. Dear friends, this is a very simple definition of the vapor. The vapor is a group term for any substance, solid or liquid, that undergoes a gaseous state. Now, when we understand the concept of the steam is a specific term that denotes the liquid in a gaseous state. Whenever supplying the heat energy to a liquid, if the liquid is getting converted into the gaseous state, then we can consider that particular term, the specific term, to be the steam. And friends, let me highlight the point that throughout the discussion of this unit, the properties of the steam, we will be considering the liquid as the water. So considering the concepts of the water, we will be discussing the different properties related to the steam. So these are the basic fundamental concepts related to the steam and vapor. Let me again inform you that these particular concepts are mainly related to the mechanical engineering. If we refer these concepts for other subjects, there are chances that the description, the understanding is different because the application, the requirement of the topics are different on the different subjects. Since we are discussing the subject basic mechanical engineering, I am restricting myself towards the discussion related to the mechanical engineering. So friends, now let us proceed further and understand one of the most important questions of this unit, the topic that is the steam formation at constant pressure. So friends, for better understanding, I am taking a simple arrangement consisting of the cylinder and piston. On the piston, as you can observe, a weight W is placed and the cylinder is filled with the water. In the first case, we are assuming the temperature of the water that is 0 degrees Celsius. And in the second image, we are considering the saturation temperature of the water. Since the water is in the normal conditions, we can observe that the weight W has maintained the equilibrium conditions with the water. There is no movement of the piston, there is no lifting of the weight W. Now friends, focus on the third image. In the third image, whenever we are supplying the external heat energy to the cylinder, the water absorbs the heat energy. The temperature of the water is increased above the saturation temperature of the water, and thus now the steam is produced. And friends, considering the density of the steam and water, the steam, it is in the gaseous state, so it is but obvious its density will be lesser than the water, and hence the steam which is produced will be collected on the above or the top side of the water. And friends, we are observing in this third image that when the steam is produced from the water, the production of the steam results into the movement of the piston in the vertical direction, and thus now the weight W is lifted in the upward direction. So the first and the simplest type of the steam which is produced from the water, that is the wet steam. And friends, as we are proceeding further in the current session, we will be discussing in detail the concepts about the different types of the steam. Let us now understand the figure 4. In the figure 4, now we are observing that there is no water. The complete water has been converted into the steam, and that particular steam is now known as the dry saturated steam. And if we consider the lifting of the weight W, we can compare that for the dry saturated steam. The weight W is lifted at a much higher heights than compared to the wet steam. It is quite visible in the image. Now friends, still we are heating the steam. Now there is no water, there is only the steam in the cylinder. And again we are supplying the heat energy to the cylinder. So now the steam will be heated. That means the dry steam will be heated. The temperature of the dry steam, that is the saturation temperature, will be increased. And now the cylinder will be attaining a new temperature, that is the superheated temperature. And friends, at the superheated temperature, now a new steam will be developed, that is known as the superheated steam. So the third concept, that is the final image, represents the production of the superheated steam. And we can observe from the image that the superheated steam will be having much energy contents. Therefore, the weight W will be lifted to the maximum height. So these are the basic concepts related to the steam formation and the different types of the steam which are formed from the water. Let me ask you one of the question, if you remember. Dear friends, in which cycle of the heat engine we have come across the term that is superheated steam? In which heat engine cycle we have come across the term superheated steam? Any student, if the student is remembering, then they can give me the answer. Very good, I have got the answer from one of the students, the perfect answer, that is the Rankine cycle. So friends, if you remember, in the Rankine cycle, in the boiler, we were producing the superheated steam. And this superheated steam was further transferred on the steam turbines in order to increase the work done by the turbine. So that was the concept of the superheated steam. Let us now proceed further in much depth related to the topic of the steam formation. So friends, this is a simple temperature enthalpy diagram for the water, and it can be used for understanding the concepts related to the steam formation. Starting at point P, we are assuming that we are having the ice at minus T degrees Celsius. Now the ice is supplied with the sensible heat. Remember friends, the sensible heat is that type of the heat which is responsible for changing the temperature of the body. But the sensible heat does not change the phase of the substance. So now when the ice at point P at minus T degrees Celsius is supplied by the sensible heat, it will remain in the same phase, that is the solid phase, but the temperature of the ice will be increased. So the temperature will be increased from minus T degrees Celsius to 0 degrees Celsius. And we have reached at point Q. At point Q, there is ice in the solid state at 0 degrees Celsius. Now friends, this ice is supplied by the latent heat. And friends, during the discussion of the refrigeration cycles, refrigeration systems, several times we have come across the concept of latent heat. Remember that the latent heat is that type of heat which is responsible only for the phase change at constant temperature. There is no change in temperature, but only the phase changes. So friends, now in the process QR, the 0 degrees Celsius ice will be melting and we will be getting the water at 0 degrees Celsius. So this heat which is responsible for the phase change from solid to the liquid state at constant temperature 0 degrees Celsius, that is known as the latent heat of ice. Now friends, we are at point number R. We have attained water at 0 degrees Celsius. This water is now supplied with the sensible heat. So again now by absorbing the sensible heat, the phase will remain the same, but the temperature of the water will be increased to the saturation temperature. So that is seen in the process R to S. R is at 0 degrees Celsius, the temperature is increased to S, that is at the saturation temperature. Now friends, again supplying the latent heat of the steam, the saturation temperature of the water, using the latent heat, now the water will be converted into the steam. But the steam will be produced at the same saturation temperature. Since we are supplying the latent heat, so dear friends, remember at point S, there will be the water in the liquid state at saturation temperature. At point T, there will be steam in gaseous state at the saturation temperature. Now friends, if we want to produce the superheated steam, then we will be supplying the heat of superheat to the steam which is produced at point T. So this dry steam will be absorbing the heat of superheat. Now the temperature of the steam will be increased from saturation temperature to the another temperature. And this another temperature is known as the superheated temperature. That is shown by point U, that is TU. The temperature is highlighted in this figure. So friends, at point U, now we can understand that at point U, we will be getting the most important type of the steam, the most energy efficient steam, that is the superheated steam. So friends, this is the basic understanding of the steam formation which is taking place at the constant pressure. This graph is very important in this theory, and this discussion, all the understandings, all these concepts, we will be using in majority of the discussions throughout the chapter. And this graph is the graph representing the temperature in degrees Celsius and the enthalpy in kilojoule per kg. So the graph is also known as the TH diagram for the water. So friends, now let me ask you the question, is the concept clear to all? The steam formation. Has all the students perfectly understood this theory? Because friends, I am telling you again and again, it is a very important theory in order to understand, and we will be using the concepts of this theory several times in the further discussions, and also for solving the numericals of the properties of the steam. These concepts will be very much useful. So friends, I want the responses from majority of the students in the chat box if you have understood the topic, that is the steam formation. Kindly share your responses or your comments in the chat box if these concepts are clear in your minds. Okay, fine. So I am getting some good responses from the students. So let us now proceed further and understand some of the important terms which we have already discussed related to the steam formation. First term, that is the sensible heat. It is the type of the heat which is responsible for the change in temperature without changing the phase of the substance. So in the sensible heat, there is only the change in the temperature, increase or decrease of the temperature, but the phase of the substance remains the same. The opposite of sensible heat, that is the latent heat. So latent heat is the type of heat which is responsible for changing the phase of the substance without changing its temperature. The next important term, that is the superheated temperature. The temperature of the steam above the saturation temperature at a given pressure is said to be the superheated temperature, and it is denoted as T sup. And friends, remember, the superheated temperature will be always greater than the saturation temperature, and the steam which is produced at the superheated temperature is known as the superheated steam. The next important term, that is the amount of superheat or the enthalpy of superheat. The amount of heat required to raise the temperature of the dry steam from its saturation temperature to any required higher temperature at a constant pressure is called the amount of superheat or the enthalpy of superheat, or it is also known as the heat of superheat. In simple, this is the heat energy required to convert the dry steam at saturation temperature into the superheated steam. And the last term, that is the degree of superheat. The degree of superheat is the difference between the superheated temperature and the saturation temperature. Mathematically, the degree of superheat, that is equal to T sup minus T saturated. So this is the discussion related to the topic of the steam formation. Let us proceed further and now understand again the most important topic of the properties of the steam, that is the types of the steam. Already friends, we have understood that there are three main types of the steam. They are the wet steam, dry steam, and the superheated steam. Remember friends, the dry steam is also known as the saturated steam, or it is also known as the dry saturated steam. There are different names of the dry steam. I am repeating once again. The dry steam is also known as the saturated steam, or it is also known as the dry saturated steam. Now let us proceed further and understand the concepts of these three most important types of the steam. The first type of the steam, that is the wet steam. From the name only, we can understand that this is the type of the steam which will be containing either the moisture or the water particles in suspension. Because of the presence of the moisture or the water particles in the suspended form, this steam is known as the wet steam. And friends, in this type of the steam, the evaporation of the water is not complete, and the whole of the latent heat has not been absorbed by the water. Therefore, we can consider that wet steam is a two-phase mixture. containing the boiling water particles and the dry steam in the equilibrium state. This statement is very important in context of the wet steam. The wet steam is a two-phase mixture containing the boiling water particles and some percentages of the dry steam in an equilibrium state. Dear students, let me ask you, is the concept clear to all related to the wet steam? Have you all understood perfectly the concept of the wet steam? I want the responses from majority of the students in the chat box. Kindly give me the confirmations if you have understood the point of the wet steam, so that I can proceed my discussion of the types of the steam. Okay, thank you for sharing the response. Now friends, let us understand the second type of the steam, that is the dry steam or the saturated steam or the dry saturated steam. When the wet steam is further heated, now it does not contain any moisture or the water particles. And since now there are no moisture or the water particles present in the steam, we can consider that type of the steam as the dry steam or the saturated steam. And friends, if we consider the analysis of the steam, the dry steam absorbs its full latent heat and practically it behaves in the same way as the perfect gas. So friends, it is very essential to consider this parameter of the dry saturated steam in order to calculate, in order to analyze the properties of the steam. And let me inform you one of the important point. The dry steam will be always produced from the wet steam. Firstly, the water will be converted to the wet steam. If the heat energy is provided, then this wet steam is further converted to the dry steam or the saturated steam. Dear students, is the concept clear to all of the dry steam? I am moving very slowly because I know that these are very important topics which we are going to use again and again in this chapter. Because of this reason only, I am asking you at each and every point and I am moving very slowly in the discussion. Now let us proceed further and understand the third most important type of the steam, that is the superheated steam. As already discussed, when the dry steam is further heated at constant pressure conditions, thus raising its temperature above the saturation temperature, a new steam is developed which is having the maximum energy, and this steam is known as the superheated steam. And friends, for the practical use of this steam, always or in majority of the applications, we are preferring the use of the superheated steam. Since the pressure is considered to be constant, therefore the volume of the steam increases with the increase in the temperature. So friends, these are the simple concepts, but the important concepts related to the types of the steam. Let us proceed further and understand the next important parameter, that is the dryness fraction of steam. The dryness fraction of the steam, it refers to the quality of the wet steam. Because friends, whenever we are using the wet steam for the practical application, it is very essential to justify the quality of the wet steam. And that quality of the wet steam is technically referred to as the dryness fraction of steam. The dryness fraction of the steam is defined as the ratio of the mass of dry steam actually present in the wet steam to the total mass of the wet steam. The dryness fraction is denoted by small x. Mathematically, the dryness fraction of the steam is represented as follows, that is x is equal to ms upon ms plus mw, where x stands for the dryness fraction of steam, ms stands for the mass of the dry steam actually present in the wet steam, mw, that is the mass of the suspended water particles present in the wet steam, and ms plus mw represents the total mass of the wet steam. Now friends, if you have understood the concept of the dryness fraction and the types of the steam, let me ask you a technical question. For wet steam, what will be the value of dryness fraction? I am giving you three options. First, understand the question. For wet steam, what will be the value of dryness fraction x? The options are x is equal to 1, x less than 1, x greater than 1. Just understand the question, understand the options, and share your answers in the chat box. The options are x is equal to 1, x is less than 1, x is greater than 1. So I am getting some good responses from the students. So the perfect answer, majority of the students has given, that is the perfect answer for the wet steam. The dryness fraction will be always less than 1. The value of x will be always less than 1 in case of the wet steam. And friends, if we consider the dry steam, then what will be the value of x? If we consider the dry steam, what will be the value of x, dryness fraction? Very good. The perfect answer from majority of the students. If we consider the dry steam, the value of x will be equal to 1. Because in the dry steam, now there are no water particles, so the value of mw will be equal to 0. So only the answer will be ms upon ms. So ms will be cancelled and we will be getting x is equal to 1. And when we consider the third concept of the superheated steam, so for the superheated steam, the x will be greater than 1. So remember these 3 points. For the wet steam, x less than 1. For dry steam, x equal to 1. For superheated steam, x greater than 1. Let us proceed further with the next parameter, that is the wetness fraction. So wetness fraction is defined as the mass of the water particles or the moisture actually suspended in the wet steam to the total mass of the wet steam. Remember friends, the definitions are very easy. In the dryness fraction, we have considered the percentage or the mass of the dry steam present in the wet steam. In the wetness fraction, we are considering the mass of the water particles or the moisture which is present in the wet steam to the ratio of the total mass of the wet steam. Mathematically, the wetness fraction is represented as wetness fraction is equal to mw upon ms plus mw, because we are considering the mass of the suspended water particles. So mw upon the total mass of the wet steam, so mw divided by ms plus mw, where the notations remain the same. Ms, mass of the dry steam actually present in the wet steam, MW, that is the mass of the suspended water particles present in the wet steam, and the total, that is MS plus MW, is the total mass of the wet steam. Dear friends, now understanding the concepts of the dryness fraction of the steam and wetness fraction of the steam, understanding the equations of both these fractions, can I write down the equation? Dryness fraction plus wetness fraction is equal to 1. How many students are agreeing with me that the equation is perfectly fine? Dryness fraction plus wetness fraction is equal to 1. We can write down this equation. Dryness fraction plus the wetness fraction is equal to 1 by substituting the equations of both these fractions. Okay, so some of the students has given me the confirmation that yes, we can exactly write down this equation. The dryness fraction plus the wetness fraction is equal to 1. Now wetness fraction already we are knowing, that is x. Dryness fraction, that is x. So we can calculate the wetness fraction, that is equal to 1 minus x. Now friends, if we consider the dry steam, in the dry steam the wetness fraction will be equal to 0. So 0 is equal to 1 minus x. So we will be getting the answer, that is x is equal to 1. And friends, the final point, priming, when the wetness fraction is required to be expressed in percentage, it is known as priming. So priming mathematically is represented as priming is equal to 1 minus x into 100, where 1 minus x represents the wetness fraction multiplied by 100, because we need to calculate this value in terms of percentage. So friends, this is the discussion of the current session. Thank you all for watching my today's session. I hope you have perfectly understood the points covered in this session related to the properties of this steam. Have a nice day. Now friends, if you are having any questions from your side related to the topics which are covered in this session, then you can ask me in the chat box. Any questions from any student related to the points discussed in today's session? Have you all understood perfectly the concepts discussed? I want the responses from majority of the students if you have understood the concepts. Okay, fine. Thank you all. See you in the next lecture.